rasa malu. Okay? Okay, so back to this example. So a person pushes a 14 kilogram lawnmower at a constant speed of with a force of 88. So immediately I told you, last time I told you equilibrium condition. What is the condition? It needs to have, what does it need to have? What is the condition for equilibrium, guys? Wake up, wake up. Good morning, bangun. What is the condition for equilibrium?
Constant speed.
Speed 0. Ataupun acceleration is 0. So acceleration is 0 is equal to constant speed or velocity. And what else? A needs to be 0.
At rest.
At rest, yes. So sebenarnya kalau nak ingat, you can remember, okay, equilibrium means acceleration equals to 0. And acceleration yang 0, apakah kondisi yang menyebabkan acceleration is equal to 0? It needs to have a constant speed or is at rest. So benda ni datang daripada acceleration is equal to 0. So what does it mean to have an acceleration that is equal to 0? You have your equation, the Newton's second law, F equals to ma. If A is 0, therefore, your F net is also equal to 0. This means that the forces on the right balance out with the left ataupun they cancel out each other. The forces on the top cancel out with the forces acting from the bottom, at the bottom. So they cancel out, so akan jadi kosong. That is how they become static, or that is how they have a constant speed. Okay, so now we look at this question. A person pushes a 14 kilogram lawnmower. Immediately we know that this is going to be our FG ataupun weight. Let me write weight because we've been using W. And this would be 14.9.81. At a constant speed, this keyword already tells me that something is A equals to 0. Is it the X or is it the Y? But this is a lawnmower. Of course, it's in the Y. Lawnmower adalah pemesen rumput. So dia akan bergerak dalam X-axis. So constant speed lawnmower ni adalah pergerakan dalam X-axis. Therefore, the net in your Fx is equal to 0. Okay, so this is our second information. With a force of 88 Newton directed along the handle. So yang ni part ni tricky sikit. So saya akan cerita balik. Kita buang balik benda ni. So I think I got a few questions on this last time and I promise to explain balik lah. Where is my, okay, let me use black. Okay. So this is our axis. Kita dah tahu our lawnmower is being pushed in the x-axis. Therefore, our axis should be parallel to the motion. So we have our y-axis and x-axis like this lah. This is our axis. Now I'm drawing the free body diagram. This is the lawnmower. We start with the weight, mg, and we know that there is a force of 88 Newton directed along the handle. If I'm pushing the lawnmower, okay, kita lukis lawnmower kecil dulu. If I'm pushing the lawnmower to the right, ini handle handle, walaupun dia buruk. Tapi kita semua kena tahu tu handle. So it's going to the right, therefore the handle is being pushed this way lah. Dia kena tolak macam ni lah kan. Kalau dia ke kanan takkan nak tolak ke kiri pula. So that is where it's being pushed. So another question that can arise is, boleh ke lawnmower ni being pushed to the left? Yes, the answer is yes. So what if the lawnmower is being pushed to the left? Therefore the motion is to the left and the force will be directed along here. So which one should I choose? Kalau tengok soalan ni, which one should I choose? Kasih masa untuk berfikir sikit.
The first one.
The first one, but why? Ada reason tak kenapa?
Angle 40 degrees.
Angle 40.
Angle 40 degrees. So kalau angle 40 degrees, okay, kita lukis Kalau angle 40 degrees, macam ni pun boleh. Macam ni pun boleh. So macam mana? Anyone else? Okay, so jawapannya, okay, fokus Jawapannya adalah dua-dua boleh. Yay. So you can pick either one. It will still give you the same answer. Okay, because the question did not specify anything. So you can choose. So let's do both, right? So we cakap directed 40 degrees along, it is directed along the handle. So kita tahu daripada atas, tapi it is 40 degrees to the horizontal. So first, you would draw it like this. Okay, so let's have another one over here. The one with the other force. Sama je, nanti kita akan tengok jawapan dia akan sama. Sebab this is in equilibrium, so it will cancel out eventually. So this would be our mg. Okay, for this guy, our force would be like this. Okay, and then I told you, okay, but free body diagram, the forces really goes out of the center of the mass. This is not wrong, but it's not the best way to write or to draw a free body diagram. So typically, free body diagrams, dia punya forces akan keluar daripada center point. So macam mana kita nak bagi dia keluar? Kita akan extend dia. So for this guy, kita akan extend dia ke sini. Okay, so we will draw it over here. Okay, so if this was 40 degrees with the horizontal, this is also 40 degrees with the horizontal. We're just extending it. It's still the same vector. Remember, vectors are arrows. Vectors is just a direction. So kalau kita extend pun, it's still the same vector. Okay, kalau saya nak resolve, what if we resolve it? Kalau saya nak resolve, saya akan resolve dia macam ni. Okay, so this is my x and this is my y, right? What if I resolve this guy? This is my x, this is my y. It's the same direction. So there's no issue if you extend it. So let's use the one that we extended because I like that one better. It makes my life easier. Okay, tu buang dulu ni. So everyone okay ke with the extending of the vector ni? The angle is still the same, okay? So for this guy, this is 40 degrees. So if we are extending this vector down here, where is our angle? It would be over here. So this is basically apa panggil? I think it's modern maths. Benda ni kena ingat sendiri I don't know how to teach you guys that. Okay. So we have our mg, we have our 88 Newton force, which is 40 degrees with the horizontal. This is still satisfied. I mean, this diagram still satisfies the question. And then we have our mg down here. Okay, next. Calculate the horizontal friction force on the mower and then the normal force. So they've given you hints lah on what other forces that is available. So they're asking you to calculate for to calculate friction and also for normal. Normal, this lawnmower is on the grass, therefore it is on a surface. We would have reaction force that is 90 degrees to the grass ataupun to the ground. Sama juga over here, we have reaction force. And for this guy, this is, if it's pushing this way, this is the motion, right? This is where we were referring our free body diagram. Therefore, the friction would oppose the motion. Friction akan oppose the motion. For this guy, motion is to the left, this way. Okay, I'm just making like a small catatan kat sini. It's not part of the free body diagram. So therefore, your friction force would be this way. Okay. Any questions so far? Is everyone following me?
No.
So no questions? All right, so let's continue. Now that we have the free body diagram, it becomes easy to solve it, right? We know that net in the fx is equal to 0. Is this lawnmower flying? Is it supposed to fly?
No.
No.
In the fy, what is the value? Kalau saya tak terbang, apakah force yang acting on me? Would I have acceleration if I wasn't flying?
No.
No, because my reaction and my normal and my gravity force would cancel out with each other. This is how I'm sitting on the chair. Kalau korang ada gravity saja acting on you without the reaction, you would sink down because there's something pushing you ataupun there's something pulling you downwards. So you are not flying because you have reaction and also gravitational force acting on you. You are the lawnmower here. You have reaction and also gravitational force. Kalau reaction force tak ada, if there is nothing countering gravitational force acting on us, we would sink into the earth. So we don't want that. So kita tak terbang ataupun the lawnmower is not flying, therefore net in the Fy is equal to 0. Sekejap my PowerPoint ni. Okay, it's done. So net in the Fy is equal to 0 and net in the Fx is equal to 0. How do we know this? Not flying. Senang je tanya. Ask yourself, is this object flying? It's not. And then net in the Fx we know from constant speed. So these are our conditions that we need to work with. Okay, so now I need more space. Let's rub this off. So now we are writing the equation. Start with your condition. So net in the Fx is equal to 0. And what are the equations for what should be in my equation? So kita lupa nak resolve tadi. Let me resolve first. That is one of the things that we need to do. 88 cosine 40, and this would be 88 sine 40. Remember, the axis that is touching the angle gets the cosine. So what is in my x-axis? We have 88 cosine 40 going forward. So that is a positive. And then we have friction going backwards. And this would be equal to 0 because this is the x-axis. Therefore, your friction would be equal to 88 cosine 40, whatever that value is. Okay, lepas kita ada free body diagram, it becomes easy. You just need to make sure your vectors are resolved into the axis and then you write it into your equation. And then next one, what is the condition for Fy? Fy needs to be 0. The lawnmower shouldn't be flying. So what is in our y-axis? We have r going upwards, positive r. We have mg going downwards. That is a negative mg. This is equal to 0. Therefore, r would be equal to mg, and m is 14 kilogram. We are referring to the object that we were drawing the free body diagram. This is the lawnmower. Therefore, the mass would be the mass of the lawnmower lah. The 14 times 9.81. So I don't know what that is. I broke my calculator last time. Was it with you guys? I think so. So 14 times 9.81. So that is your answer. Friction. Oh, lupa. We need to include units. This is in Newton. This is also in Newton. The end. Any questions about this one? Okay, ada soalan tak?
Okay.
Okay, so everyone understands. Okay, that's great. Next one. Okay, so this one, example. A crate of mass 50 kilogram lies on an inclined plane. So let me draw that. So when you approach a problem, you always need to try to visualize. Kalau saya nak solve problem pun, saya akan lukis. I never go without diagrams. Well, it's hard to solve without a diagram. So please make sure you draw. It will help you. So a crate of mass 50 kilogram lies on an inclined plane. This guy is supposed to be touching the inclined plane. Find the maximum inclination angle. Is asking you to find theta. To keep the crate to stay at rest on the incline. So it wants to stay at rest on the incline. So our box punya tendency of motion is of course going downwards lah. Imagine yourself on a slide. If you sit on it, you would blongsor lah, right? So you are going to have a motion that is going downwards. We label our x-axis parallel to the motion. This will be our x-axis. And what is the perpendicular component to the motion? It will be y. Even though it's not moving, We want to know what is the tendency of the motion. So that is our x-axis. So let me draw that. This is our x-axis and this is our y-axis. Okay. We want to stay at rest in the x-axis. So that is our condition. Is my box going to be flying on this inclined plane?
No.
No. Therefore,
Net Fy equal to 0.
Fy equals to 0. Betul. Always ask yourself about that. What is the condition? What is net in the fx? Is it MA or is it 0? Tapi MA kita tak masuk lagi. So this is in equilibrium punya example. So given the coefficient of static friction is static is 0.25. So what is coefficient of static friction? We have mu. It's called mu. Mu s. If it's coefficient of kinetic friction, it is mu k. So this is mu s 0.25. And the coefficient of kinetic friction is 0.2. Okay, which one should we use for this?
Static.
Static, because it is at rest, right? Thank you. So we need to use mu s, even though they've given us both. You don't have to use all the information. Sometimes it's just to trick you guys, okay? All right, so now let's draw our free body diagram using green. So this, we start with our box. Gravity is always pointing downwards. So that is your mg. And we would have to resolve our mg extending my x-axis and y-axis. My angle is over here. My angle for the free body diagram would be in between my mg and my new y-axis. This is theta. Okay. I still forgot how to find this. Nanti bila saya ada masa saya akan cari macam mana nak kira the theta ni. But if you guys know, then you can share with your friends. So this would be mg cosine theta, and this would be the resolve mg sine theta. So immediately we know that there is a force pulling the box downwards. It is from gravity, but only its component. And then when this box is on the surface, we know that we will have reaction force. And what else? What am I missing here? Friction, yes. What color should I use? Blue. So friction is opposing the motion, always. So now that we have our free body diagram, it looks easy now. We start with our condition and we write our equation. So what is our y-axis? It's this guy. And our x-axis would be this guy. So apa-apa yang dalam x-axis, letak dalam equation x. Apa-apa yang dalam y-axis, letak dalam equation y. So we start with our condition. Net in the fx is equal to 0. And you have, what do you have here?
mg sine theta minus f.
This is equal to
0.
Okay, so f is equal to mg sine theta. We know the mass, we know g, we don't know what is theta. Let me just write that. So m is 59.81. Sine theta is our friction. Next, net in the fy is equal to 0. What is in our equation for y?
R minus mg cos theta.
R minus mg cosine theta. And this would be equal to
0.
0. So R is equal to mg cosine theta and 50. This is 9.81. This is cosine theta. We still haven't solved anything yet. Okay, what other equation do we know about friction or about reaction force? Ada tak?
Friction equal to mu r.
Yes, friction is equal to mu r. So let's try to relate friction and r because kita nak solve for theta. So let's try that. I also don't know. Typically, I just try to see what is the relevant equation. But in this case, it's more easy for you guys because we know for chapter 3, kita ada this bunch of equations je. It's not like we don't have to like put chapter 2 inside chapter 3, right? Okay, adalah sikit. But mostly it's confined within chapter 3 lah. Okay, so we know that F is equal to mu R. So let's do that. Sekejap saya kemas sikit. Okay. So friction is equal to mu R. In this case, our mu is S because this guy is not moving. That's great. Makes our life easy. So friction in this case is 59.81 sine. Oops. I think my handwriting is improving. Alamak, baru cakap. Tiba-tiba dah buruk. Hello. Hey, berapa point ni? Okay, 9.81 sine theta. And this is equal to apa? Mu S. Mu S is, we have the value 0.25 and we solve for R just now. So this is 59.81 cosine. 59.81 and tak muat lagi cosine tu, pindahkan dia sikit. Okay, so this is cosine theta. So what do I do if I have sine on one hand and cosine on the other? Benda ni saya dah banyak kali dah cerita. What do we do with this? Jadikan dia tangent, yes. So tangent is sine over cosine. So bring your cosine over to the other side. But first, let's do our cancel out thing. So 9.81 cancel out with 9.81, 50 cancels out with 50. And then I'm bringing cosine to the other side to make it into a tangent. Tangent. So sine over cosine akan bagi saya tangent. And then I have tangent theta is equal to 0.25. I solve for theta. This is easy. Inverse tangent of 0.25. And you would get something with degrees. Okay, it's a mystery. I don't have my calculator. So that is how you solve it. Okay, any questions about this one? Macam mana nak tahu sine over cosine is tangent? Kena hafal benda tu. I also don't know. There's no hint on that. This is maths, so I don't know how to give you hints on that. So kena ingat benda tu, sine over cosine is a tangent. Sama macam kita hafal resolving vectors mg sin theta, mg cosine theta. Okay, we actually have a lot of maths in physics. Okay, so no questions, everyone's okay? Wow, that's great.
Okay.
So everyone understands. That's good. Okay, so we covered this one both. Next one. Okay.
Doktor?
Ya.
Yang degree kita, yang angle kita dapat tadi tu kan memang apa? Angle yang untuk bagi dia at rest lah.
Betul. So this is the maximum inclination. So maximum maksudnya yang paling besar lah. So angle yang kita dapat kat sini adalah angle yang paling besar yang kotak ni boleh stay at rest. Kalau lagi tinggi daripada tu, contohnya, saya tak tahu jawapan dia apa. Contohnya jawapan dia 50 degrees. If you go 51 degrees, then the box will slide. So this is the maximum angle sebelum box tu bergelongso. Okay? Okay, next one. The exercise tak untuk korang ni? Oh tak ada, lepas ni cerita pasal linear motion. Okay, last one before we go into linear motion. This is our last example. What is the minimum horizontal force to stop a 40 kg box from sliding down an inclined plane? So lebih kurang macam soalan tadi. Tadi tanya pasal maximum angle to keep the box at rest. Maksudnya angle yang paling besar sebelum box tu menggelongso. Yang ni pula what is the minimum horizontal force? It's not asking about theta, it's asking about minimum horizontal force. Kalau inclined plane of coefficient friction 0.2. So kat sini dia tak bagi static or kinetic. So we are just going to say it's mu. So that is fine. Just use it as it is. So this is 0.2. Given that the plane is 50 degrees, theta is 50 degrees. Box mass is 40 kilogram. Max minimum horizontal force. Okay. Tak apa, kita lukis dulu. Saya tak dapat gambarkan lagi. Okay. So box. Okay, let's draw a free body diagram as usual. Center point. We have our mg. Motion is going to have a tendency to go down. Therefore, this is our x-axis. This is our y-axis. Always parallel and perpendicular to the tendency of motion ataupun the motion. So this is our x. So I'm going to resolve mg. This is 50 degrees. Saya buat dulu untuk korang nanti ada exercise nanti. Jangan seronok sangat Make sure you know how to do this. Okay, so this is going to be mg cosine theta. Lama tak cukup tempat. Betul. Okay, what else? What else do we have here?
R.
R, which is perpendicular. What else?
F.
Friction, yes. Okay, everyone is like senang sangat dah free body diagram ni. Betul, dah jadi senang kan sebab kita dah tahu. C. Okay, so now we want to find the condition. Is my box flying? This is, I'm going to ask you guys over and over again. Is my box flying?
No.
No. Therefore, Fy is equal to 0, or net Fy. What should be my net Fx?
0.
0, because kita nak tahu apakah minimum force untuk bagi box ni tak bergerak. From sliding down. From sliding down maksudnya daripada bergerak. That is what it means. So both our condition is 0. Kenapa kita belajar benda ni walaupun kita tahu benda ni equilibrium? Sebab kita baru belajar equilibrium. Kita kena tahu keyword-keyword untuk identify soalan equilibrium. Sebab lepas ni kita akan belajar pasal linear motion which is not in equilibrium. So kena tahulah condition yang menyebabkan sesuatu objek tu equilibrium. Okay, so we know our conditions. Yay! So we can write our equations now. So a net in the Fy is equal to 0. What is in my y? It's positive r minus mg cosine theta. This is equal to 0. I don't know what my r is, but I know what my mg is. It is 49.81, and this is cosine 50. Great. So this would be something in the Newton. Next, net in the Fx is equal to 0. Kita buat laju-laju And then what is in my x-axis? It is mg sine theta. This guy is to my right ataupun to the right of the x-axis. Kita akan assume is a positive. And friction is opposing that, so it's a minus 0. Again, F is equal to mg sine theta. The equations are pretty easy. So this is 49.81. And then we have sine 50. Wait, what is the minimum horizontal force? To stop. Okay, so sekarang ni F adalah 40. It shouldn't be. Kejap. F is equal to mu r. Okay, kita abaikan ni dulu. It needs to be 0, but I think we will have a force here. Yang kita tak masuk lagi sebenarnya. Okay, tak apa. I'm just going to introduce to you guys. Okay, so F is equal to mu r. So, kalau kita dapat value kat sini, tapi dia tak go back to this guy, dia tak, macam nak cakap, dia tak sama. So, it's going to be wrong. It's okay. Let me retrace my steps. Let's Adam dulu, dia tanya pasal minimum horizontal force. There is another force acting on this guy. It's not supposed to be equilibrium. No, sorry, it's in equilibrium, but there is another force. I'm sorry. So akan ada another force here. Okay, so this is the trick question here. Okay, so F equals to mu R. So mu 0.2, kita dah tahu R apa. So that's great. Can someone calculate what R is for me? Kita kena tahu value dia this time.
252.23.
252.23. Okay, 252.23. Okay, so this is 252.23. F is always mu R, right? 0.2 times 252.23. What would that give me?
50.4.
50.4. 45. Okay, this is Newton. So I'm sliding down. What is the minimum horizontal force? What is the minimum from sliding down? Okay, sorry. So I wrote my F to the right, right? Kita ada mg, kita ada friction. So kalau mg sin theta ni lagi besar pada friction, maka dia akan tertarik ke bawah. So kalau saya nak prevent dia dari tarik ke bawah, I need a pulling force from the top. Okay, sorry, this question caught me by surprise, but I thought it's the typical equilibrium. So this is going to be our F unknown. Let's call this FA ataupun FP lah. Okay, so let me reiterate this question. So what is the minimum horizontal force to stop a 40 kilogram box? To stop a 40 kilogram box from sliding down an inclined plane. Okay, so kita ada mg sin theta, which is from gravity. We have friction, and this question is assuming that we need an extra force untuk halang box ni daripada jatuh. Maksudnya kat sini friction ni tak cukup untuk halang dia dari jatuh. Okay, so typically kita akan cakap, okay, friction is large, so it's going to keep this guy at rest. However, it's saying that there exists another force that helps the friction to stay, that helps the box to stay at rest. Maksudnya dia tolong friction lah. Dia tolong friction, dia tambah force dekat arah yang sama dengan friction untuk prevent the box from sliding down. Okay, everyone faham tak soalan ni sekarang? Faham tak what I'm trying to say here? Why the F is upwards?
Faham.
Faham Okay. Okay, so I hope everyone is on the same page as me. So now we write our equation. So net in the Fx needs to be 0 because we are trying to prevent the box from sliding down. So apa yang ada dalam equation kita adalah mg sin theta minus F minus Fp. This is our unknown force. Okay, so we know what friction is. M is 40, 9.81 sine of 50 minus 50.45, and then we have whatever that force that is helping us to keep it at rest, and this should be equal to 0. Can someone calculate this for me? What is Fp?
250.15.
250.15.
Yes.
Oh, besar juga. Okay. Okay, thank you. Okay, let's go back to this question. Apa yang berlaku sebenarnya? Okay, so mg sin theta. Tadi kita kira mg sin theta 40. Boleh tak kirakan mg sin theta? Sorry. Mg sin theta 40, 9.81 sin 50. Berapa tadi? This would be
300.
300 300 tepat?
0.6.
6, okay. So this is 300.6. Kita kira friction kita tadi 50.45. Tak cukup. Maksudnya kat sini force ni lagi besar daripada friction. It's going to slide down. Maksudnya we need other forces to help us to keep this box at rest. So apa force ni kita tak tahu apa yang berlaku kat sini, but we are going to assume someone is pulling this box from above untuk halang box ni daripada jatuh. Sebab kalau kita tengok pun ada box atas gelongsong, we have a worker or someone that will hold the box in place, right? So this is called the F pull. F pull ni adalah direction dia ke atas. Kita try to make sense of it because kita nak halang dia daripada jatuh. So therefore the force untuk halang dia dari jatuh would be the opposing motion, right? Opposing the motion. So FP is this way and our x-axis punya equation would be positive mg sin theta, which is 300. We have friction, which is 50.45, not enough to keep the box at rest. Therefore, FP should be 250.15 Newton to keep everything at rest. So 50 plus 250 is equal to 300. They cancel out each other. The box has a net force of 0 in the x-axis. Okay, so that is what happened. Ada soalan tak? Sorry. Okay ke? Faham ke? So no questions. Okay, even the chat box is like krik-krik sangat. So I hope everyone is okay and focusing. Next one, we are going into our next subtopic. This is object in linear motion. So we're talking about non-equilibrium situations. We talked about equilibrium just now. Now it's non-equilibrium. What is the condition for non-equilibrium condition? So A is not equal to 0. It's easy. So tadi A is equal to 0. Now it's A is not equal to 0. The net force must be in the direction of motion. So let's say we're talking about the box. This guy is sliding. It has motion. We will assume that it has some acceleration. Maybe it's 10. Therefore, net in the Fx is not equal to 0. It's going to be MA. What is MA? M is the mass of the box. Okay, mass. Kenapa saya tulis singkat-singkat? Mass of box and A would be the acceleration of the box. Okay, so it's sliding down. It's not in equilibrium. Therefore, your condition is net in the Fx is equal to MA. Oh yes. Doktor hari tu doktor ada bagi tahu tentang hubungan antara koefisien dan angle, tapi waktu tu doktor kata doktor akan confirm kembali. Okay, yes, saya terlupa. Nanti saya jawab kat WhatsApp pasal ni, saya lupa nak cari. Okay, thank you for reminding me. Saya akan cerita nanti. Okay, so saya introduce dulu pasal ni. Net in the Fx is equal to MA. What is our M? It's the mass of the object. A is acceleration. So the net force must be acting, the net force acting on the object must be in the same direction as the direction of motion. So if A is this way, your F is also this way. You follow lah. Okay. So F net equals to MA. So forces for an object not in equilibrium, F is equal to MA. Okay, benda yang sama je kat sini. If the forces are in 2D, F net is equal to net in the parallel ataupun this is net Fx plus net Fy. Perpendicular is Y and parallel is X. So sum of perpendicular components ataupun net in the Fy, sorry for that, net in the Fy is equal to 0 and sum of the parallel components in the X is MA. So why is it 0? Kenapa kita assume dia 0 kat sini?
Tak terbang.
Not flying.
Betul. Terkejut saya. Jawab. Laju korang jawab bagus. Dah faham dah. So we are assuming that the motion is in the x-axis only. But what if saya nak sebut nama siapa? Saya tak nak sebut nama saya. What if Adli is flying? What would be the net in the Fx for Adli? He's flying. What is the net in the Fx?
0.
0. If we are assuming Adli is flying, betul-betul vertical lah, power gila kan? Dia macam pakai roket. So, but the net in the Fy is equal to MA untuk someone yang terbang ataupun for an object that is flying. For a rocket, but rocket pun ada that slant sikit. Ada slant sikit kan? So, it's not exactly net in the net in the fx is equal to 0. Kalau roket tu tadi lah ingat macam tu dia start macam ni. Kita cakap pasal roket sekarang ni. Bukan pasal idly. So roket ni, bila dia naik atas space, when it goes into space, dia tak adalah go straight Dia go, kita nampak macam dia go straight, tapi sebenarnya ada that slight angle. So basically, when we have a slight angle, we would have some component in the x and some component in the y. Tapi untuk memudahkan kita akan cakap, okay, it's just flying upwards, which is net Fy is equal to ma, and net Fx is equal to 0, which is what we talked about Adli. Sorry Adli. Okay, so itu saja. Korang kena tahulah, if it's flying or if it's moving in the x-axis, that is your ma. Okay, next. Read and understand the question. Of course, always draw, visualize and sketch the situation. Yes. Identify the object. This will be your mass. In some cases, there may be more than one object. If you have two boxes, one is like this, pulley system, then you have another box here, you would have two free body diagrams. Jangan lupa. This would be M1G, and this is M2G. Okay, kan ada dua. Adalah dia punya free body diagram, whatever that is. Okay, so don't forget. Identify all forces acting on each object. Yang kita belajar adalah weight of object, normal force, frictional, tension, and any other external forces such as F pull, F push. Okay, F pull or F push. Okay, benda yang biasa kita tengok sini lah, F pull and F push. We are ignoring air resistance always because that's just, I don't know, physics memang dia suka ignore air resistance. It's complicated. Lepas tu dia ignore. Okay, next. What else? Sketch the free body diagram, of course. Ni siapa tak buat ni, sila rotan diri sendiri. Saya dah lukis banyak sangat free body diagram. Tolong lukis juga. This will help you write the correct equations. If your free body diagram is incorrect, your equation is most likely to be incorrect as well. Because kita write equation based on our drawing. Kalau drawing kita salah, equation kita pun akan salah. Unless you have some superpowers that you can visualize in your brain. I can't do that. If you can, boleh, alhamdulillah. But okay, please always draw the free body diagram. Memang ada markah most of the time. Choose a 2D rectangular axis. What did I talk about? This one. Wherever the motion is. Kalau motion kita macam ni, this is our x and this is our y. Kalau motion macam ni, dia ke atas, this is our x, this is our y. What if motion kita ke sini, macam ni, this is our x, this is our y. Always look at your motion, the parallel, x-axis will be parallel to the motion and perpendicular to the y. Okay, what else? Resolve all forces into the chosen axis, baru tulis equation. Identify your condition. Is it equal to 0 or is it equal to MA? And then write your equation based on your free body diagram. Okay. Okay, this is nothing. Ni apa? Oops, dah ada jawapan pula. Duplicate jap. Have we done this one? Belum kan? Oh, dah buat dah. Tapi saya buat lepas ajar linear motion. Okay, never mind. Is it? Yes, dah buat. Ini pun dah. Belum, ini belum. Duplicate slide. Okay, kejap Tengoklah jawapan, tak ada masalah. Nanti kena buat balik juga. Okay, let's do it together. Tension is 281. Okay, let's see if we get the same answer. So a 45 kilogram box, we have around 9 minutes. I'm going to do this fast. So kita tak ada exercise hari ni sebab saya nak catch up. So 45 kilogram box is kept from sliding on an inclined plane. I'm always catching up, right? Because kita ketinggalan 2 jam daripada kelas lagi satu. Because we missed out one class. That's okay. You guys are still with me until the end of semester, so it should be fine. So a 45 kilogram box is kept from sliding an inclined plane by a string parallel to the plane. So tendency of motion is going downwards, of course. Therefore, kita akan assume the string is connected somewhere here lah kot. Let's just draw it first. I don't remember. If the coefficient of friction is 0.2, so it's giving us mu is equal to 0.2, and the plane is 50 degrees to the horizontal. What is the tension of the string? So it's asking here, what is T? So this is our string. If I were to draw my free body diagram, let's do this together during our last few minutes of class. Let me ask Alisa. Is Alisa there?
Yes.
Okay, what should be in my free body diagram? Name one force.
Resultant force.
Okay, tapi untuk free body diagram, apa yang saya patut lukis kat sini?
Friction force.
Friction, okay. Which way should friction go?
To the left.
To the left, okay. So Alisa is saying to the left. It's from the center. Thank you, Alisa. Aina, what else?
MG
MG ke mana?
ke bawah.
Ke bawah. Okay. So kalau saya nak resolve macam mana?
So, sekejap.
Anyone wants to help Alisa?
X-axis, mg sine 50.
Okay.
Y-axis, mg cosine 50.
Betul ke dia ke bawah ke atas? MG cosine theta ni.
Ke bawah.
Sebab
resolve.
Okay, betul lah tu. Because we are resolving, therefore our vector should be in between our resolved vectors, right? Kalau saya letak mg cosine theta ke atas, vector pula kat sini, so kita sandwich apa sebenarnya? Kita tak sandwich apa-apa. What is here? Nothing. So don't do that. Always sandwich your vector. Saya panggil sandwich, and always make sure your vector is in the middle. Panggil sandwich. Okay. So what else? Thank you, Batrisha. Akila, what else?
Normal.
Normal. Where should it be?
Align with the mg cos theta.
Okay, great. That's a good answer.
Upwards.
Very specific. I like that. Okay, so reaction is along the same line as mg cosine theta. Correct. Okay, next, what else? What are we missing here? Daniel Harith. What else? Let's use yellow. Hello, Daniel Harith, are you there?
Ada betul.
Okay, what else? What are we we have a string here. What should I have?
Tension.
Where should it go?
Sorry.
Where should the direction of tension be? Direction.
To the box.
To the box. Tell me.
I guess away.
is bawah. So ke sini.
Not sure lah doktor.
Okay. Betul lah. Betul. Macam mana? Apa ni? Janganlah ragu-ragu. Kena confident. Okay. Thank you so much. Farid. Farid is Farid ya? Selain daripada tension, reaction, friction, mg sin theta, mg sin 50 and mg cosine theta or 50. Ada tak kita tertinggal apa-apa lagi?
Tak ada.
Tak ada. Okay. Kalau tak ada, apa is my net in the Fy?
Zero.
Zero. Sebab
Kita ada acceleration.
tak ada acceleration. Okay. Good. Well done. Okay, next. Saya nak tanya lagi ni. Firna, what should be my net in the Fx?
Zero.
Why is that?
Because no acceleration.
Because no acceleration. How did you know there is no acceleration? Which part of the question? Kat mana yang Firna identify dia tak ada acceleration tu dalam soalan?
Oh,
Apa keyword dia?
Box sliding.
Is kept from sliding, yes. So this is the keyword. Yang cakap, oh, immediately when I read this, I know that A equals to 0. Kita jangan bantai, kita tak boleh cakap, oh dia ni nampak macam equilibrium. Let's just use net in the F equals to 0. Jangan. Look at the question. Sometimes they trick you. So kena fahamkan soalan. Is kept from sliding. Dihalang daripada menggelongsor. Maksudnya tak ada acceleration lah. Dia dihalang. So A equals to 0. Okay. So that is your condition. So let's write the equation really quickly before we end class. How many minutes do we have? Oh, tak cukup masa. Okay, never mind. Okay, so that's it for today. I hope everyone understood how to draw a free body diagram and faham macam mana nak tentukan soalan yang equilibrium ataupun tak. Okay, so I'll talk to you guys next class. Bye-bye. Take care, everyone.
Thank you, Doctor.
Thank you, Doctor.
Have a great rest of the day.
Thank you, Doctor.
Thank you doktor.
Thank you, Doctor.
Welcome. Bye-bye.
Doktor,
Yes.
cap from sliding tu maksudnya at rest eh?
Ha.
Oh, okay. Thank you.
Welcome.